a few words about themselves and their career path, and then the rest of the time is for Q&A.
I can hop on Zoom in my office if you think it'd be better, if it's easier.
That might be easier.
It might be easier that way, yeah, so
Yeah.
if you could zoom in and then each person, yeah, that might work best.
So can you look if our career panelists are here? Mark Abatoso is here,
Mark, yeah, there's Mark,
and
there's Lucy here.
Lucy down.
And
Lucy
Lucy's here,
is
she's
here.
waving,
Great.
all right.
She's waving.
I'm here.
And we could hear Lucy and Mark, can you say hello so we can hear you?
Hello.
All right, we can hear Mark too. All right, so I guess let's wait for Keegan to log in here.
Let's say go ahead with these two. He'll be on.
All right, well, all right, so let's see, I'll go with last names alphabetically. So I'll let Mark first say something. So Mark, go ahead.
I'm always first alphabetically when it comes to AB Abataswe.
There you go.
So thanks for having me, Demos and James. So Mark Abataswe, current. I'm a Blue Origin structures engineer, formerly a Boeing aerospace or Boeing commercial airplanes structures engineer. 2013 aerospace engineering at U of M.
That's not work. Go ahead, continue. Don't worry. I'm just trying to turn the camera around so it's facing the audience so that you could see them.
So Mark, could you say a few more words also? I mean,
So not sure.
I think he's waiting for me to stop.
Yeah,
the
I mean,
camera.
I could ramble on.
Oh, okay.
I mean, I could ramble on forever with a bunch of useless nonsense, but yeah, I was good at I guess I'm a unique student. I'm originally Canadian, so I attended U of M as a permanent resident. I'm still a permanent resident, actually working in the aerospace industry. So that's rather unique. If there's any other students who are in the same situation, don't let it discourage you. It's rather it's possible. I was listening to some of the talks as well. Another interesting note I like to point out is I never had a NASA internship. I didn't have any internships when I was a student. Again, it's hard for a permanent resident secure internships in U.S. industry as a student. I did have the fortunate luck of doing research under Demos for a year or two. I worked on the HASP project, some X-ray detection as a student, and then I worked on the some physics research as well. So that's where we're at.
Right, so I guess we're going alphabetically, so would be Keegan would be the next one. So a little bit of a path of where you started. I mean, you're special in the sense that you're through the NASA's pathway program. So if you could say a little bit about how that worked and what you did at NASA as a pathway, or what you're doing at NASA as a pathway.
Definitely, yeah. So I guess I started as an undergrad student at the University of Minnesota here, studying aerospace engineering. Graduated 2020, and then I continued my graduate work here as well in the same department. And then I had a lot of experience under Demos as well in the CubeSat lab, working with like attitude control of small satellites. And then that kind of helped me, and along with some other opportunities, to become a Pathways intern at NASA Goddard Space Flight Center. And so the Pathways program is a little different than the center internships that like we talked about earlier in some of the other sessions. And it's kind of like you can think of it kind of like a pipeline for students. They try to have you work part-time or alternating semesters throughout your undergrad and or graduate school in the hopes of eventually becoming a full-time employee once you're done. And so right now I'm working in what's called the navigation and mission design branch, which is a lot of work for like guidance, navigation, and control for deep space missions for satellites, which is really enjoyable. I did some work on what's called the Auto NGC project, which is essentially one of the major projects at the center to create a suite of software to run most satellites that Goddard's launching autonomously. That way they don't have to phone home to Earth and have someone in the loop to make things kind of run a little easier. That's kind of where I'm at right now.
Thank you, Keegan. And I guess I will let Professor Dunn go next.
Sure. Hi, everybody. I'm probably a little non-traditional for this group. Let's see, my career path started with a degree in textiles and apparel in clothing design. I was at Cornell for my undergrad, stayed there for my master's to do the same thing, clothing design. And I swear this will come around to aerospace at some point. About halfway through my undergrad, I got really interested in protective clothing and functional clothing. So that's kind of where I started towards where I am now, which is really more in wearable technologies and smart clothing. So concurrent with my master's degree, I did a degree in electronics. And then when I went to do my PhD, well, I didn't really intend to do a PhD. I really intended to go live in Ireland for a little while because I have a lot of family there. And I wanted to work, at the time I wanted to work at Media Lab Europe, which was a spinoff of the MIT Media Lab. Unfortunately, they went bankrupt right after I arrived. So I had kind of looked around for some backup plans and ended up doing a PhD because Ireland is a small country and there really wasn't much smart clothing going on in Ireland at the time, except in academic research. So I did a PhD, continued along the path towards smart clothing. And, during that time period, I realized I really loved research. And so I sort of, became a professor, which was not something that I thought I would do ever. So how I intersect with this group, well, I guess technically, since I was an undergrad, my mother has been telling people that I designed spacesuits, which is a total lie. And about maybe 12 or 13 years ago, I had a visit from somebody at Johnson Space Center who was interested in smart textiles and smart clothing. And he thought we could do a collaboration. I went down to visit, and the person at JSC who runs external collaborations and university relations was like, you guys should do more than just a project. You should have a symposium. So anyways, long story short, my class has been collaborating with JSC mentors for many years now. All of which is supported by the space grant, which we very much appreciate. And sort of through that, I've built up a lot of relationships and, ended up working on more and more human spaceflight problems. And then about 5 years ago, in my department, we hired another faculty member who works in functional clothing and this is Brad Holshoe, who co-directs the lab that I run. And he comes from the world of advanced spacesuits. So he did his PhD working on mechanical counterpressure spacesuits. So between the two of us, we shared an interest in aerospace applications. And so that has only increased in the last few years, which is all to say that you can take a very non-traditional path and end up back at NASA.
All right. Thank you very much. All right. So with that, I think we're going to open up the floor to questions to our panelists about things you want to know about their career paths, how they advice that or questions that you may have on what's the best thing to do and how to tailor your or how to look for interesting opportunities to work at NASA or work with things related to NASA. So let's start asking questions. All right, James.
So I have a question for Mark. Can you talk about how rocketry, you did rocketry as a student, you continue to do rocketry. How did that impact you? I don't think Boeing ever had you do rocketry particularly.
No, Boeing did not have me do rocketry, but yes, that's correct. So yeah, I'll take credit. I was the one that introduced James to rocketry. So Minnesota has a huge rocketry, team and components, all because one day I decided to go to school at University of Minnesota. Yeah, I was the first student or the first club's team that had a team back in 2011. At the time when I did it, it was kind of it was something cool to do. And I saw it as a kind of resume builder. It was like a chance to apply, what we were learning in classes at the time, right, to build something like hands-on. And there was other projects at the time. There was like the Formula car, the solar car. There was like, James was doing ballooning and payloads at the time. But I kind of like rockets a little more. I was like, let's get into this rocket business. So then a couple of years passed, we did a couple of years of rockets, and my rocketry experience paid off. It helped me get my job with Boeing, to be honest. So when I did my interview at Boeing, as a student, many of the questions are kind of like, can you tell us a time when, you had to, you struggled with a language barrier or dealing with someone, from a different culture. So it turned out our team members on the rocket team was a Japan exchange student. So I had to, tell that story, and that's what they were looking for, a student, someone who could work with someone from another, language or culture and be able to relay that technical information. Another one of the questions was, have you ever worked with composites? And at the time in the rocketry, our clubs, we were looking at, building composite bulkheads, sandwich panels. We were looking at doing composite layups on our rockets. So again, I shared with Boeing, right? I said, yeah, I have a lot of, I have in the rocketry industry, we were doing composite layups, and they were looking for students who had composite experience. So when I got hired on with Boeing, I like to think it was the rocketry aspect, or my experience had a lot to do with getting my foot in the door at the Boeing company. And then now I also do. So now I'm also like, I think my title is project assistant for the Wisconsin Space Grant Consortium. They do a couple of competitions. They do their collegiate rocket competition, and then they do the First Nations launch. So I've been working with First Nations launch for the last 5 years, just kind of encouraging and inspiring the First Nation American Indian students to get into STEM. So I believe one of the students presented on it this morning, and I missed that talk, unfortunately, from the Fond du Lac Tribal College student.
But now that you're at Blue Origin, I told everybody there was going to be a Boeing engineer here, so I feel
Yeah, I saw that. I was like, I guess James missed the update. Yeah, so former Boeing engineer. All of my experience so far has been at Boeing. I did work the last 8 months to a year at another company called Spirit Aerosystems, which is a supplier to Boeing in Kansas. So I've worked big company, I've worked small company, and now I'm working rocket company.
So Blue Origin, that is more rocketry for you, or not really?
No, Blue Origin is bigger but smaller than Boeing as far as company wise. So it's kind of like the work culture and the dynamics a little bit different at each company. And it's different than NASA. So even listening to the students talk about internships, some of the things are the same and some are different.
I was wondering if each of the panelists could talk to the importance of networking with different members of different schools and different organizations, and how that helped you get where you are.
Well, all right, let's see. Well, Keegan, you want to start, and then I'll go to Professor Dunn.
Yeah, I can start. Yeah, networking, kind of when you first get into the world of like career space, networking can kind of come off, especially if you're a STEM student, as kind of like not useful. A lot of people will call them like soft skills, but networking, once you kind of get into your career space, you realize how actually important it is. And it's going to sound really cliche, but I promise it actually is like really beneficial. And especially from kind of like outside your core group, like when you're in undergrad, you have your main friends or your main class, and they may go off and go to some other company than you once you graduate. And that's really helpful. But also, like you mentioned in the question, other colleges, that's also really helpful because you don't know where they're going to end up. Their program might be in a place much different from where students from your program might end up. And actually, like, for example, on like Tuesday or Monday, I'm flying out for an interview with a student that I met through work who was like a non-traditional student, came from a different undergrad, and they actually ended up going to the same grad program as me, but I would have never kind of gotten that opportunity without kind of networking outside of my like normal space.
Yeah, I mean, I agree. I think I guess most of my career has been in like emerging areas, areas that don't really exist yet. There aren't like big industry, there aren't, you know, it's not really a thing like that has a really well-defined structure. So in that sense, you know, every opportunity has to be sort of created. And I think creating opportunities usually relies on there being somebody else involved. Like it's hard to do anything totally isolated. So you know, you will need connections. You will need to run across the right people at the right time. And you know, for instance, my whole journey with NASA started from, you know, someone who was an intern at the time doing a project. Actually, I think he was a Pathways intern at the time, assigned a project to figure out if smart textiles could be useful in this space. And somebody told him that there was a lab at the University of Minnesota, and he had a girlfriend in Minnesota at the time. And so he was coming back and forth. And so he knocked at my door one day, and you know, it kind of built from there into like a very large and widespread, you know, it's now, I think our program is now 9 or so universities that have been involved, and many interns that have been sent, and many career paths that have been redirected, you know, all because of a sort of chance encounter. And I think I could probably tell you dozens of those stories from my career. I think things like conferences are really useful for stuff like that. They seem to provide a context that, you know, supports people having reasons to talk to each other, which is the way that interesting conversations get started. You know, we've really missed that in the last couple of years. I find it really difficult to manage to do the same thing online, even though I know it's possible. I just haven't quite gotten over the hurdles of trying to do this virtually, versus just being in a room with someone in a coffee break and they've just given a talk that made you ask some questions, and, you know, you have something to talk about, and it kind of goes from there. So yeah, I mean, I think even if it's not your most favorite activity, and I know I find networking exhausting, and but if it is really useful, and when you meet the right people, it's easier because, you know, you have shared interests, and you know, you have a productive conversation.
Professor Dunn, can I ask one question? This is like adding on to that. So how long ago did that Pathways intern come to you? Like random question.
I'd have to look it up. James, do you remember?
Like I think that may have been the intern that mentored me as a CSC mentor, and then got me on the path of being a Pathways intern, because they worked in the wearable technologies lab.
Oh no, that's Nick. That's Nick.
Oh, it was okay. So different. Okay.
No, this
Yeah,
was
so it was
this was
big.
several years before that. The guy's name is Corey Simon.
Oh, okay.
Yeah, but Nick was one of our Pathways interns. Yeah.
Okay,
I'm glad he mentored you. He's wonderful.
I was gonna say that it's a perfect example of like networking all coming full circle.
And actually, Nick came to us on his own networking journey. I think he sort of cold emailed our lab. He had heard about it in some way, and I think we just got an email from him randomly once, like, "Hey, can I work on research in your lab?" And that went from there.
Mark, do you want to add anything to that?
Sure. So, so going into industry, you know, out of college, my kind of experience was career fairs. So it was kind of like I didn't know anyone who worked in industry at the time. And then given that I didn't do any internships, I didn't have, you know, really any connections other than academia like the professors. You know, so I went to a lot of career fairs. And that's where I ended up meeting the Boeing company, and found the right manager who liked me and gave me an interview, and the rest was history. So take advantage of career fairs and networking, and just talking to whoever you can at whatever career fairs you can get to. What else? I think one of the other speakers touched on it, your college friends. So keep in touch. Like I keep in touch with my college friends, right? Like we graduated almost 10 years ago now. But I try and keep in touch with everyone, and we're all kind of working spread out around the country, different companies. You know, so if I ever want to change, and, you know, I'm thinking a new company or new location, I can easily ask, you know, one of my old college buddies, say, you know, what's the culture like over there? You guys got any, you know, opportunities or openings, and can you help me get in? And it does work, I guess. I mean, when I got on with Blue Origin, there's a couple of guys that I graduated with that work at Blue Origin. So I'm kind of joining the party late, but they kind of give you the rundown of what to expect for the interview, and they kind of give you the heads up which was, I felt great because I felt, you go in an interview cold, you don't know what to expect. You don't know how to prepare. But if you got a friend who works there, they can give you that, this is what I did when I interviewed, or this is what, they had the questions they had me answer. So that's great for networking. But networking is not everything. Sometimes you can go in cold to a company, right? So using social media as well. So I'm on LinkedIn and just kind of, putting your skills on LinkedIn. A lot of recruiters will look on LinkedIn and kind of hit you up, if they think you're a right fit for a position. So you don't really need to know anyone at the company. Just getting to know those recruiters or advertising yourself, marketing yourself well, gets you those opportunities.
Let me just add, I agree. Networking with your professors can be really, really, really useful. And in the kind of like, help me help you vein, the better you know them, the easier it is. If I can say meaningful things about you, about the experiences we've had together, and if I know your interests, then I can know, oh, this opportunity is going to be great for, this individual. But also the relationships you have with your classmates are going to be pretty unique. And I think like this is, undergrad and grad school is like the last time you kind of build some of those like I don't know, vulnerable relationships, where you are truly sort of open. I think once you enter the workplace, things get a little more distant and a little bit more formal. Informal relationships, that's a good one. And so those people, forever you will have be able to talk on a different level with them than maybe the rest of your coworkers, I think. So, those relationships can be really, really important.
And then,
Go ahead.
oh, because I have one quick thing to add on like the LinkedIn thing for the networking. Don't be afraid. Like, so we've been talking a lot about networking with people that like friends and like work friends and colleagues and like other students. Don't be afraid to also on LinkedIn, if you are interested in like a certain job or a certain company, to reach out to people. They'll also like network with you. A lot of people are really open to that. And that's also like another kind of vein of networking to explore, I'd say.
All right, thanks for that. David, you had a question that you had raised?
Yeah, so this is kind of a question again for all the speakers here. I've been working with 3D printing professionally for about a year and unprofessionally for about 2 to 3. I'd like to know your opinions on kind of two sides of it. One, where do you see 3D printing? And I mean, outside of just like the rapid prototyping, where do you see that in the future with aerospace? And also, what technologies do you see as the most important, specifically for aerospace, but also just in general, which technologies do you think in 3D printing is the most important?
I can maybe start in on that. So I'm not super familiar with 3D printing. Back, when I was in college, it was kind of in its infancy. We used a couple of 3D printed parts for our rocketry components. And then once I started working, I'm a structural analyst, but it's mostly primary structure on airplanes. You're looking at, composite layups and metallics and things like that. You're not looking at 3D printing I don't know if well, not currently. We're not going to 3D print a wing for an airplane, right? Maybe in the future, that's a plan. But I know companies such as the Boeing company, they're looking into 3D printing like big time. So they're kind of developing, the not just the PLA and the plastics, but they're looking at the metallic stuff as well. Sure. And they're starting to switch away to that, or switch over to that kind of manufacturing process more so, right? So they're kind of looking at, what existing products do we have and how can we make them cheaper or better or lighter or stronger using a different fabrication technique such as 3D printing, right? Whether it's the layup or the deposition or whatever it is. And as far as space goes, I did interview with a company about a year ago that was looking to produce satellites in space that just were there for 3D printing. They were looking to just fabricate parts in space. So all you do is you'd have this, satellite going around. It would have the powder or whatever material you have on there. And then anytime you need a part in space, it would just go and spit out that part. You would just kind of send the upload, send the drawing to the satellite, and the satellite would kind of just spit out the part. So
Cool, that's cool.
it's It's in its infancy still, I think, but I mean, it's going to be booming here shortly in industry.
Thank you.
And I guess kind of on my side, I'm not too involved with like structures or materials, but I haven't checked in on it recently, but I've seen some murmurs and research going into kind of a similar thing that like Mark mentioned of like 3D printing, but this time instead of satellites on surface of different planets. Like say we have a mission to Mars, I know, or I've heard of some research into potentially how we can utilize 3D printing on the surface of another planet, because that's a really like adaptable resource to have on a space mission, especially from like a mission planning perspective. Like, oh, your tire on your rover breaks and you need a part of an axle, or you can print it, or you ship 400 kilograms of spare parts. And then
Right.
really looking into that for kind of adaptability for mission design. And I can't think of any projects or things at NASA off the top of my head, but I bet if you did a little Google searching, you might find some interesting things like that.
For wearables specifically, our most common additive manufacturing technique is knitting. But 3D printing is useful in blending soft and hard goods, so being able to apply rigid sections to a flexible textile.
Sure. Thank you.
All right, other questions? I'll ask. What were you not taught as an undergraduate that you wish you had been taught and was very useful in your careers? And I'll start with you, Mark, because you're smiling pretty hard.
I'm
there.
just thinking, I'm like, there's always been times where it's like, they didn't tell me about this part, or they didn't tell me. I feel like in college, just basically what I got from college was the complete technical side of it. And that was it. I mean, I don't think I got any of the soft skills side of it. And I kind of wish that was enforced or informed, or, a little more, exposure in college prior to going into to industry. You kind of learn it on your own. Eventually you learn to work as a team, and you learn to work, and you learn to do, technical presentations or public speaking or networking or whatever it is, right? But again, you're not really formally trained on any of that in college. I'm sure I can think of other things, but I'll let the other presenters answer as well.
They seem to be quiet, which means they had very good undergraduate educations that taught them everything they needed to know, right?
Well, my undergrad was in fashion design, and I work more in engineering now than anything. So you can imagine there was a fair amount that wasn't covered in my undergrad. But I think that's probably true of any undergrad. I mean, there's probably a few exceptions where you're like trained on a really narrow path, and then you just do that path. But the world changes too fast for anyone to learn everything that they need in their undergrad. So I would say maybe one of the better skills is like how to learn stuff and how to not be afraid of, maybe I would really emphasize that. I think the more senior you get, the more tendency there is to be afraid to be out of your depth, because you have so much more depth at that stage. And if you can fight that, I think it keeps your brain a little bit more nimble, and keeps you humble, and opens you up to totally new ideas. So I would say always keep learning. I think there's probably never going to be a time, I think, where I feel like I know all the things I need to know. Design probably does a better job of teaching some of those soft skills, but there was certainly a lot of like technical content that I've had to pick up over the years.
And then this is going to sound cliche, but I would also like mention soft skills. I felt like the U of M and the aerospace department specifically was really good at kind of throwing you into those difficult like team working scenarios where you have to work with a team and solve like some really difficult problems in courses. And that's where a lot of those experiences come from, that are kind of like your quintessential interview questions of like, name a time you had to work with a really, really difficult team member and how you overcome it. And those kind of things sound cliche, but once you start getting into industry and careers, that's a really useful skill to authentically learn. And then kind of more on the technical side of things, this is pretty applicable, at least to some of the presentations I saw in where you're doing kind of design in a STEM field where you're either like mechanical design or software design. In your classes, you design something and it works once and you submit it and you get an A. But in industry, like things will break and things will go wrong, and you have to ensure that things go wrong in a good way. And that is a very, very, very big emphasis, at least in the work that I've done. And kind of learning how to back up a claim you make, like say you're working for someone or you're some company and you design something and they're going to ask you like, how do you know it's going to do this? And you say, oh, I did this analysis. And they're like, how sure are you? And why are you sure? And then that's where you really have to put some effort into, which you do get some experience in that in classes, but that is like one really big area that I found that was helpful to learn more in.
And then if I could also jump in here. So another one as well, school is very, very kind of rigorous. There's always kind of like one answer and it's got to be to like 4 decimal places. When you get into industry, it's not really, there's never really any one correct answer. It's kind of like a range of answers, right? You got to have a tolerance, like a plus minus on your calculations. You got to have something kind of in the back pocket to protect, right? And you're kind of always balancing, especially in structures, you're always kind of balancing performance with weight. And it's kind of like, you could squeeze all the performance out of it, but then if the loads increase or something, and then your part's going to fail. Or vice versa, you could bake in all this weight and be capable of all these things, but then you got all this extra weight and management's going to, so management's always kind of over your shoulder watching you. And you're always trying to balance the equations or balance the answers. So it's never really one answer. So I don't know, if I feel like the academic approach is correct, right? Like you need to learn the equations, you need to learn how to make calculations, and learning those decimal places and then that one right answer. But just know that once you get into industry, and maybe this is different for NASA, maybe NASA is a little more rigorous than industry, especially if you're doing research and R&D. It's kind of pi is 3.
I've seen in some research documents pi equals 5. So
I think of that as sort of the difference, one of the differences between science and engineering. In science, sometimes at least there's one answer. In engineering, there's always more than one. They're not all the same quality or the same benefit. So there are better or not so good answers, but there's rarely just one answer in engineering, especially.
And I can tell you why in school we don't do those kind of things. They're hard to grade. Other questions? Yes, Ben.
I was wondering, just probably for all the panelists, as you go forward, you start to realize that maybe you had things that you were wrong about, sort of in the way you approach things. It'd be just interesting maybe for students to hear, how 10 years into your career, you realize, wow, I really kind of, could have done things differently or had a different attitude, or, this was really important to me at one point, and now I realize that might have held me back or pointed me down a direction that, was fine, but maybe not as optimal as it could have been. Just curious if you have any thoughts on that.
Sounds like an interview question.
I can start. I would say my younger personality tended towards resisting criticism, I would say. And even though I was trained in design where it's all criticism, my brain would want to explain away why the criticism wasn't really valid. And I think as I've matured, I've embraced criticism a little bit more and started to realize, it's not all about trying to be right the first time. So, and I think like the more you can listen to feedback and to leverage feedback, things get better, and so it kind of trying to overcome that knee-jerk response, I think, has been useful.
Mark, Any guide on that?
I'd say just learning to be flexible, and I feel like I've always kind of been that way. You kind of have goals, you kind of have objectives, you kind of think you might know the path. I always struggle when I meet someone who knows exactly what they want to do and where they want to go, because I'm like, I don't really know. I mean, I'm just gonna take the next step, and it's all these little incremental steps, and each step, leads to different opportunities, and you take that path, and it leads to different opportunities. But as far as like, the technical stuff, don't get attached to your work. I think, again, one of the speakers was kind of like, oh, I did all this work, and then they come and they criticize it or they change it, right? Because especially if you're new, you're not going to know all the ins and outs and the, common mistakes, right? So don't get attached. And I even see that in my line of work as a structural analyst. Designers or analysts will get attached to a certain method or configuration, and then they get upset when people oppose it. And it's like, just throw it out there. Don't get attached to it. If someone smarter than you or higher up than you or more years experience than you says that's not going to work, or that's incorrect, or we don't like it, try something else. Be willing to just be flexible in your engineering methods. And then as career-wise, same thing with your career. I mean, I never knew when I moved to the United States and went to school at Minnesota, I never knew I was going to work at Boeing commercial airplanes in Seattle. That was never a goal. It happened, and I loved it. I enjoyed it. And then even now, I'm at Blue Origin. It's kind of just the next step in the chain, or the next, opportunity given at this time, comparing all the opportunities I have. Who knows where I'm going to be 5-10 years from now. So again, it's just being flexible.
Yeah, I'm kind of the new guy on the block, so I don't have any age-old wisdom that's like served me well in industry. But kind of two things for me. I would also like to echo the flexibility thing, especially when you're kind of like when you're young in college. Like my first internship, I pretty sure I got a phone call before a class my junior year in, I think, like April, and then I had an internship starting in May where I had to move across the country. And that first internship was like a very helpful thing to have on my resume in my early career. And if I just kind of sat back and saw, oh, I only have 4 weeks to figure out how to get out there, I could have like missed out on a really good opportunity. So being flexible is like also very helpful, and like you don't know where it'll take you. And then one other thing, like being a grad student, I kind of have one foot in the door of being a college student and kind of one foot in the door in like being a professional in industry. And in college, and kind of just kind of throughout the aerospace industry, there's this really big culture of like hustle and like grinding and burning yourself out. And don't be afraid of like kind of pushing back against that, and especially once you start your career, of like prioritizing your mental health and taking a break. Like when you're done with work, go home, like have your days off, and like really prioritize that. And that can really help you perform better at work, but also just kind of enjoy things better. So don't be afraid to kind of, I don't want to say push back, but like second guess that kind of mentality once you start working on things.
So if I could back up Keegan's last comment there as well, work-life balance is very important. So when I started working at the Boeing company, my mindset was 150% work, grow, trying to advance the career. I think I was the overtime king in our group of analysts. I was the guy who was, I'll work weekends, I'll work evenings, what do I got to do to, get ahead around here? And then after, the first couple of years, it was exhausting, and it wasn't really getting you anywhere. So, learning to dial that back and just kind of, there's a time for work and there's a time for the rest of your life, and you should be working for your life, not, your work shouldn't be your life, right? It should, they kind of go hand in hand, go with each other. So keep that in mind when you start your career.
Yeah, there are definitely times, even as an intern, where it's like, oh, I need to pull a 55-hour week because we got some crazy deadline and something went wrong. And we really have to like get things done. But then there's weeks where, oh, I'm going to take off Friday and work 30 hours this week and go skiing. Just because like that's just like that work-life balance.
All right, well, we're at 4:35, so that time went by quick. So thank you very much to the panelists. Over back to you, James.